interesting. Burette is a particularly useful piece of equipment because it allows us to measure out a fixed volume of solution. Rather than measuring how much we're pouring in, where we might use a measuring beaker or a conical, flask and measuring cylinder, which allows us to measure what we're pouring in, this thing is particularly useful because it allows us to measure what we're taking out. They even come with their own holders. That's a burette holder. There is a top and a bottom to a burette holder, and it says it on the thing. It switches on the top, it's the right way up. Okay, so that goes on stand. Burette goes in, and it holds it nice and gently. Now we're going to do a reaction, and we know that the accuracy of these things isn't too hot. And that's basically because you tend to use measuring jugs and conical flasks for mixing things in. It's not really meant to be a measuring device. And that's actually what we're going to use for mixing in here. Now the convention is that you have the alkali in the bottom and you add your acid to the alkali. But the convention is acid in there, alkali in here. And because we're looking for a colour change, we need a white tile, which will help us with to spot the colour change. Okay, so that sits on top of that. That goes on there. Just be a little bit careful with the burette. There is a temptation to hang the burette inside the conical flask. But then you can whip the tips off these burettes, which decreases their accuracy when you're measuring stuff out. So if you make sure that your burette is, at least so you can slide the conical flask out from underneath it, so don't have it dangling in. Okay, so that's the basic experimental setup. And I want you guys to get to this stage before you start getting the chemicals out. So you'll need to get everything set up, desks clear, all that sort of stuff before you start getting it. Now, in an ideal world, we need to measure out 25 millilitres of alkali in here. In an ideal world, which piece of equipment would we use to do that job? Not measuring jug.
Conical flask.
We could use a measuring cylinder, and actually in this case we are going to use a measuring cylinder because we don't have the alternative. But if we wanted a really accurate measurement, yeah, it'd be the volumetric flask, the thing that looks like this, a much smaller version of that. We do have some 25mm ones. If we wanted real accuracy, which we do in this experiment, because this is specifically about volume, so accuracy is quite important. But in the absence of a 25mm volumetric flask, we need to use the next most accurate piece of kit, which is the measuring cylinder. Okay, so measuring cylinder. I would like you, rather than trying to pour the chemicals out of there into a measuring cylinder, please can you pour them into beakers. But I'll leave out these board pens because alkali looks very much like acid, so you do need to know which is which. Okay, so alkali. How do I go about measuring something into a measuring cylinder? What are the two things over there? Come on, Leslie. Meniscus, yeah, is important. And remember, it's the bottom of the meniscus that you are measuring to, not the top. So this is the 25mm line. So. And what else do I need to do to check the meniscus? Go on, Billy.
Eye level.
Eye level, yes, it is. So down to eye level, and pour in 25mm of. And this really does. It is important to get as accurate as you possibly can on this. Can't stress that enough. Okay, so that's a little bit over, but I'm doing it quickly, so that's it's not too bad. Okay, so 25ml of sodium hydroxide solution. And that goes in there. Okay, and this is where the methyl orange comes in. Once you finish with this, if you can put it back in the front, just so there's no chance that we can spill it over. Do bear in mind that this is a chemical in its own right, so we don't want too much. 2 drops is easily enough. Because if you start adding too much of that, it is a chemical in its own right, so it starts to play with the reaction that we're doing in the conical flask. So don't go overboard on the methyl orange. So there we go, nice and yellow reactions we're doing. Interestingly, when we do this experiment properly, we won't be able to use the methyl orange So the aim of this experiment is to measure with 25 millilitres of alkali in here, how much acid do we need to put to that to bring it to neutral. That's the aim of this experiment, is to find out what volume of acid neutralises 25 millilitres of alkali. So the aim for you guys, today's just a bit of a play around and to get used to using the equipment, but when you do the experiment proper next week, we'll do one to get 25 mils and get the acid, and then we'll do it without the methyl orange, because you can't boil it with the methyl orange because you get methyl orange in the air, which is no good. You can fill the burette using these little funnels. Main problem with the little funnels is when you put the little funnels in, it makes a nice tight seal. And the only place for the air to come out when you're pouring the acid in is to come back through the funnel, and then you start getting acid bubbling over and all this sort of stuff. You get little bubbles bubbling back up. So you guys need to get a little piece of cardboard, fold it up, and just pop it in with the funnel, and that will give a place for the air to escape. And again, just make sure that we're not getting acid and chemicals and what have you dripping around the classroom. So a little bit in, funnel in the top. Then to fill the thing up, make sure that the door is closed down at the bottom, and put it on the floor. Now this thing will hold 50 millilitres of, well, we'll measure out 50 millilitres of acid, but actually it holds more, it holds about 60 millilitres of acid, so don't sort of exactly measure out 50 millilitres and then think this thing will be full once you pour it in, because it isn't. You need to fill the bottom. So if you then pour in your acid, and pour it so that it's over the naught line, so that it's almost up to the top. There we go. Okay, so can you see how I filled it the naught line's there, but I filled it over the naught line. The reason for that is because we actually also need to fill this bit for it to be an accurate measurement. So you guys have to bring this back down to that naught. So open the door. And again, accuracy really is absolutely key there. So just the bottom of the meniscus just touching the top of the line. When you've done that, though, you will have a fully charged and ready to go burette. So that is now full. It's on its naught line, and the little spout at the bottom is also full. So that burette is full and ready to go. So it's all charged and ready. Okay, then comes the exciting bit, because you get to add acid to the alkali. Okay, and not much happens for the start of it all. See how the indicator stays yellow whilst I add this? And actually it will do that for quite a while. You can add quite a lot of acid. But sooner or later you'll start to see, can you start to see a colour forming in the conical flask? See there?
Yeah. Peachy colour.
Yeah. So we're starting to get, I don't know whether you can see that, it is very subtle. Colour change in this is very subtle. And colour changes actually are a difficult way to measure things with the colour change, because it's quite sort of subjective, and the colour changes are very subtle. But if you keep going, so again there we go, we've got a bit of pink in there, give it a swirl, and that pink disappears. Now, your task, when you start to see the pink appearing in the conical flask, that means you're getting close to the cut-off point. Your task is to find that cut-off point. Remember, when that solution goes to pink, it's then acid. It's gone acidic at pink. So when that thing is pink, it's all become acidic. And if it becomes acidic, you've actually gone too far. The point that we're looking for in this is the change point, and literally that can be right down to one drop. I did one of these on Monday, and